Hi, this is Smart Academy. I am giving physics classes for CSI, just net, IITG, whatever physics exams we have. I am giving classical mechanics classes. In these classes, I am discussing about rigid body dynamics. Today, I am going to discuss about moment of inertia of thin lamina derivation. See here, moment of inertia of thin lamina. So this is so for this one derivation part I want to explain today. This is a lamina, thin lamina. Next, this is the axis x dash. This is y dash 0. This one origin, length of the lamina this one, width of the lamina this one, this side. So here this is L by 2, this is L by 2. So just take, if you want to derivation of the moment dimension, take one elemental strip here, elemental strip. This is distance x from y dash. So this is the situation. So for derivation we have to follow 3 steps here. First one, this is thin lamina, density of thin lamina, that is mass by, see, mass of the lamina mass, this one, length, the thin lamina mass capital M, length of the lamina L, and width of the lamina is small b. So here the area of the lamina is b. This is total mass by total area. See, density of the thin lamina. First step this one. Moving second step. This is elemental strip we taken from the thin lamina. The length of the thin lamina, that is not, sorry, this is length of the elemental dx. Next, it is the elemental strip is x distance from y dash axis. So elemental mass, this is the total mass which I have taken, that is elemental mass, this much only, that is equal to density into A into dx. See, area into dx, it will go A into dx. So delta equal to, what is delta? M by LV. What is area? See here, see, area is means this is the elemental strip of area. This is the breadth is b and length is dx. So b into dx. See, b cancel here, m by l dx, that is equal to d. This is elemental mass of the thin lamina. See, this is the total mass of the thin lamina. This is elemental mass, already we got now. So we are moving to moment of inertia of this thin lamina about y dash axis, about this axis. So integrate dm into x square. See, it is generally moment of inertia formula is m into r square. Here we taken thin lamina elemental mass, that is dm. It is distance y from the y dash x square, so dm into x square. So integrate the elemental mass is from 0 to L to 0 to, see, this is L by 2, this is L by 2, this is positive, this is negative. So the elemental mass extends from minus L by 2 to plus L by 2. This is a total mass. So that is extend from minus L by 2 plus L by 2. So the integration also will be like this. See here, minus L by 2 plus L by 2 dm x square dx. So this is, we are moving one more step. See here, what is dm we will get here. So don't keep here dx here. So we will get after that. So here minus L by 2 plus L by 2 dm equal to m by L dx x square. Then m by L take common, minus L by 2 2 plus L by 2 x square dx. Okay, from this you will get from this, so if you integrate you will get total answer here, that is equal to m by L x cube by 3. It limits minus L by 2 plus L by 2. See m by L by 2 whole cube into 1 by 3 minus plus L by 2 whole cube into 1 by 3. We get m by L cube by 8 into 3 L cube by 8 into 1 by 3. We will get L cube by 24, L cube by 24. So finally you will get m L square by 12. This is the moment of inertia of thin lamina. This is the moment of inertia of thin lamina. So here we follow 3 steps. First step, areal density. The second step is elemental mass, and third step is we are moving for 3 steps. For any rigid body, if you want to calculate moment of inertia, we have to follow 3 steps.